All right, we're going to be working on graphing trig functions this week as a continuation from last week. So remember, the sine function basic graph looks kind of like this, but it goes on infinitely left and right. Well, what happens all of a sudden when it doesn't just say sine of theta and you're just graphing the parent graph? All of these other things are happening. Well, this is what those things are. So a number attached to the left side that's being multiplied by the trig function is called the amplitude, and it affects kind of the tallness of the graph. This number on the outside that's being added or subtracted, a plus or minus number, is called the vertical shift. Just like regular parent graphs, it tells you how far to go up or down on the graph. All right, and I'm going to erase this stuff as I go. Then, and then inside, a number attached to the theta. Remember that theta divided by 2 is the same as 1/2 times theta. This value that's attached to the theta impacts the waviness, kind of speeds it up or slows it down, might be a way to think about it. And then the last value, the k value, is called the period shift. And that just tells you how far it's going to move to the left or right. And remember, when it's inside parentheses, you're going to pick the opposite value. And then I'll go over each one. In fact, I'll take a second to do that now. All right, so the amplitude is the number that's being multiplied to the left of the trig function, not the theta, but the left of the trig function. And that essentially impacts the height, the tallness. So if it's an integer, it's going to be taller. If it's a fraction, it's going to be shorter, right? That's the amplitude. The next one is the vertical shift. And that's any number that's being added or subtracted, but on the outside of parentheses. And that's where you go up or down. Here is the big tip. Are you listening? The amplitude and the vertical shift change the y values when you make a table of values. These two things impact the y values. So if the numbers on the outside of parentheses change the y values, what do you think happens to the numbers on the inside parentheses? So let's talk about a number that's being multiplied by theta. That's the b value. So you could have like 3 theta or maybe theta over 2. Remember, that number impacts the waviness. And then, and by the way, the period for a sine function, one complete sine cycle is called a period. And this b value, this is how you decide what's happening. You take the normal period for sine, cosine, secant, and cosecant is 2 pi, and you divide it by the absolute value of b, and that gives you the waviness of the new graph. For tangent or cotangent, its normal cycle is, or normal period is pi, so it's pi divided by the absolute value of b. Then the phase shift, which is also on the inside of the parentheses, you're going to take the opposite of k and divide it by b. And that is how it moves left or right. And you got it. If it's on the inside of the parentheses, it's going to impact the theta values. or sometimes the thetas and the x values kind of interchange. So inside the parentheses, the x values get changed. Outside the parentheses, the y values change. All right, let's come back to this graph right here. So here is the normal parent function of a sine function. Notice right here where the theta is 0, the sine function is 0. At pi halves, halfway between 0 and pi is pi halves, we're up here at 1. At pi, we're back to 0. At 3 pi halves, we're down at -1. And at 2 pi, we're back to 0. In fact, I have those values right here on the table. And here are the thetas. And under the y are the y values. All right. So now, when you go to make the changes to the graph, this is the big recommendation. Do the outside values first. Change the y values and then go on the inside. All right, so 3 sine means we're going to multiply. 3 times sine means multiply. So look at these y values. We're going to multiply those y values by 3. So 3 times 0 is still 0. 3 times 1 is now 3. 3 times 0, 0. 3 times -1 is -3. 3 times 0 is 0. All right, we've taken care of that. This now says add 2. Well, 0 plus 2 is 2. 3 plus 2 is 5. 0 plus 2 is 2. -3 plus 2 is -1. 0 plus 2 is 2. And as soon as you figure that out, you're actually going to move those values, replace those y values, boom, those are the y values, those will be the ending y values. So now we're going to start on the inside of the parentheses. All right, so remember to find the period, we have to, this is sine, so we have to take 2 pi, we're going to divide it by the absolute value of b. Remember, this says 1 over 2. So the absolute value of 1/2, well, the absolute value of 1/2 is 1/2. So I'm going to multiply top and bottom by the reciprocal. That's going to cancel. Well, 2 times 2 pi is 4 pi. So that's going to be the new period. So instead of it going from here to here, the new graph is now going to go from here to here for one complete cycle. All right? But those other things are going to be making changes also. So here's a way to think about that. If the new period is from here to here, what's that relationship? How much bigger, how much longer is this compared to the original? Well, it's twice as long. So guess what? You can, twice means multiply. Well, you can multiply each of those by 2. And we're going to go ahead and put those values right here. 2 times 0 is 0. 2 times pi halves is pi. 2 times pi is 2 pi. 2 times 3 pi halves is 3 pi. And 2 times 2 pi is 4 pi. All right. So I'm going to erase everything on the inside now. And now we just have to do the phase shift. You guys can pause this and retake notes or kind of pay attention to what's going on. So now, the last thing we have to do, we've done the vertical shift. We did this one. We just took care of the period. And now we have to do the phase shift. And remember, the phase shift was the opposite of k divided by the b. Well, k is pi force, so we're going to subtract, it's a negative pi force, divided by 1/2. Well, again, we're going to multiply everything by 2 over 1. Well, the 2 and 4 can cancel. 2 goes into 2 once. So we have to shift everything to the left, so negative pi halves. So when we're done with everything else, we now know we have to move everything pi halves. That means subtract. Well, 0 subtract pi halves is negative pi halves. Pi subtract pi halves is positive pi halves. So 2 pi, I'm going to write 2 pi is 4 pi over 2. Subtract pi halves. Well, 4 subtract 1, that's 3 pi halves. 3 pi is the same as 6 pi halves. 6 pi subtract 1, that's 5 pi halves. 4 pi is the same as 8 pi halves. 8 subtract 1 is 7 pi halves. So guess what? We have all of our coordinate points, and we can go ahead and plot, change it to a different color. So at negative pi halves, so if this is pi halves, right about here is negative pi halves, we're up there at 2. And then at positive pi halves, right there, we're up there at 5. And then at 3 pi halves, which would be right here, we're back up at 2. I should just put 3 pi halves right there. And then at 5 pi halves, so right about here, not right about, there, we're down here at negative 1. And then at 7 pi halves, we're back up there at 2. And if we wouldn't have shifted everything pi halves, look at, we would have been here between, let me put that in a different color, between here and here, which remember, that's what the period was. The period was 4 pi. The phase shift was, we shifted over negative pi halves, the amplitude was 3, and the vertical shift was positive 2. So now we can go ahead and remember, you have to do it curvy. Let's see, we were down here at, oh, right there, negative 1. Boom! That is the final. After all of those changes are made, that's what it looks like. And notice, we started with the outside numbers and we made those changes to the y values. Then we made the changes, we completed the inside task, and we made those changes to the thetas, or the x values. And once we got our coordinate points, we plotted our points, we redrew our line. So now, cosine, you're going to do the same thing.